In this video, we are going to discuss section 5.5 from the book. Okay. So, do you remember that when we did the spring mass system, right? What was the equation there? We had my double prime and then plus gamma y prime and then plus k and then y and then equals to, we have some function on the right hand side, right? So some external forcing function we call external force, right? So this external force, sometimes the external force may be continuous, you apply the same or the time dependent external force all the time, but sometimes you may want to apply a force for a little bit and then stop it, right? So you apply the force and you turn on the force and then you apply with a constant value, okay, or certain time dependent function. You apply the force and then you stop applying the force, so turn off the force, okay? So in such case, how do I handle how do I model these type of equations, and then how do I solve these type of equations? That is the thing that we want to cover next, okay? So for that, so first thing we want to do is so for that we will define some type of function that works that way, okay? So let us define a unit step function first. What do you mean by unit step function? So we denote by ut or ft, or sometimes we denote by u0t or f0t, like that, okay? So this is the function, this is the piecewise function, which is 0 for t less than 0. This is 0, right? So for t less than 0, the function is 0. For t greater than 0 or equals to 0, the function is always 1. You see that? This is the function. This is u0t, or you can say ut. This is called unit step function, okay? On the left of 0, it is 0. On the right of 0 or equals to 0, it is 1. Okay, that height of the function is 1 basically. So this function is also called Heaviside function, okay? But sometimes you may want to turn on that 1 after a certain time, right? After t equals to c, and then left of c it is 0 and right of c it is 1. So how do I do that? What you do is you shift this function c unit to the right, right? How do I shift the function c unit to the right? You replace t by t minus c, right? You replace t by t minus c. So when you do u t minus c, then we denote this also by uct, okay? So what you do is you translate ut c units to the right. So this is what it looks like, uct, or you can write ut minus c, okay, which is same as 0 when t is less than c. We are just shifting this function to the right, okay? So 0 for left of c and then 1 for right of c, okay? So sometimes you may want to use bigger than 1, right? For example, if you want to make this height like say 2, then you can write 2 times uct, right? So that will give you, basically the height will be 2, right? So 1, 2. So it will look like this is c, suppose, and then you will have like this, right? So 0 on the left, right? And then 2 on the right. So 2 on the right. So you can do that way. But the thing is here, what we want to do, sometimes you may want to do for some functions, right? Some functions say like that type of function. On the right side, you want to increase the force with time in the exponential with the exponential function. What you can do is you can do 2e to the t and then uct. So you can basically multiply by some functions to make the way that you want it. All right, guys. Okay, so these functions u0t, you turn on the force at 0 and you leave it 1 all the time after 0. Here uct, you turn on the force at c and then you leave it all the constant value 1 or 2 or whatever you want to do. So you will leave it forever. But how do you model this? What is the function that start at some point and end after some point, okay? After some time it wants to end and then become 0, and then you want to start at some point too. So how do I model that function? How do I write that function? So if you want to turn off after a certain time, let's say turn off after d, right? So how do you do that? So this function uct, basically uct turn on at c, right? uct basically turn on at c. and then keep constant all the time, right? Keep 1 all the time. But how about u dt? U dt, you suppose d is bigger than c, okay? So suppose d is bigger than c. So how do you do that? It will look like there is c there, right? There is d there, right? So d is basically, it is 0 everywhere up to d, right? And then you turn on after d. But which function is bigger in the sense that, see, here is c, here is d, right? So this function is 1, all the values after c, but this function is 1 only after d. So it looks like the first function uct has more 1 values than the function d, right? So what you can see here is you can subtract u dt from uct. Subtract means you cancel all those u dt from uct. So what is u dt? You remove, basically. Subtract means, right? So this is u dt, right? Let me use a different color for u dt. So this is u dt, right? So this is u dt. Let me have that. So this is basically u dt, right? So this is uct. So if you remove u dt from uct, what you will see is you will see this graph. You see that? So this is the graph for u, cd, and then t, right? So ucdt is basically uct minus udt, which is 0 for all the values except between c and d, left of c and right of d, right? And then 1 if the value of t is between c and d. So basically you turn on at c and turn off at d. This is the unit step function that turn on at c and turn off at d. Let us see one example here. What I want to do in the example is, so write this function ft equals to 5 between 0 and 2, t minus pi between 2 and 4, and e to the t between for greater than 4. Okay, so how do I do that? So it says between 0 and 2, right? What is the notation for between c and d? We do ucd. Similar to that, what I'm writing here is 5 times u0t, because u0t will imply 1 between 0 and t and 0 everywhere, right? So what I'm going to do here, that's why, is 5 times u0t, 0 to t, that is 1 between 0 and 2, okay, plus t minus 5 times u to 4, right? u to 4t plus e to the t times u4t, because we don't need two subscript here. The two subscript means you want 1 between those two subscripts, those two numbers, right? Here, all the values of t greater than 4, you want 1 times e to the t, right? That's why I'm writing e to the t times, that is 1 for t greater than 4. You see that? Now what we do next is I want to use that formula, okay? So u cd equals to uc minus ud, right? ud, but don't forget t here. So that will be u0t minus u2t, right? And then u2t minus u4t, and then u4t only, because there is just u4t. If there are two subscripts, you just subtract the first one minus the second one. You see that? Now what you do is you simplify. You distribute this 5 times u0t minus 5 times u2t, t minus 5 times u2t, t minus 5 times u4t. I'm distributing all these to all of these, okay? Now what you do is you try to group, like u0t, there is only one u0t. So, but u0t is basically 1 for all t greater than or equals to 0, right? And then you see that, so our t is greater or equals to 0. That's why I just write 5 times 1 for u0. u0t is just 1. Now, how many u2t are here? One is 5 times negative u2t. Another is t minus pi times u2t, right? So you group them. Okay guys, the last thing you do is group the u4t. So there is t minus pi times negative u4t, that negative sign comes here, okay? So I'm writing t minus pi, and then because I'm taking the negative sign, so it will be negative of e to the t u4t. You see that? So this is how I write this piecewise function in terms of the unit step function, okay? So we can always write a piecewise function in terms of the unit step function. And this is what we do, because we will have a Laplace transform. We'll have to find out the Laplace transform of a piecewise function, okay? So we will first change into the unit step function, and then we'll find out the Laplace. So the last example was basically we were given the piecewise function, right? And then we were trying to try to write this piecewise function in terms of the unit step function or the heavy side function, right? Now we do just the opposite here. So here the function is given in terms of the unit step function, and you want to write in terms of in the piecewise function form. Okay, so this is the question. Write into the piecewise function for ft equals to t minus 1 times u1t, okay, 2 times t minus 2 times u2t plus t minus 3 times u3t. You remember that if you want to write in the piecewise form, you need like u and then cd is how much is that? It is 0 if t is less than c, right? And then t is greater than d, you see that? And then 1 if t is between c and d, right? So it is c and then d, right? So this is how we define it. So never mind if there is an equal to sign in one or other, so it doesn't affect. Okay, so this is how. So you want to write in that form, you understand? So how do I write in that form? Is we will try to distribute this. So u1t, t times u1t minus 1 times u1t, that's what you distribute. Similarly, you distribute that 2t times u2t plus 4 times u2t and plus t times u3t minus 3 times u3t. Look at that, it has t here, right? This has t here. And is there anything that has t? This one has twice t, so you can break into t and then another t, right? And then there is also t. So but it doesn't have, since there is u2t, so we should relate 1 with 2 and then 2 with 3. Okay, so you will group that way in the subscript. Okay, so what I want to do here is there is t times u1t, so I want to break this into two terms, t times u2t and then t times u2t, both are minus, right? So that I can combine this with that one later. Okay, I will factor out t and then write t and then u1t minus u2t that way. Similarly, here is 4 u2t, right? For the 4 u2t, and then there is 3 u3t. So I want to connect this u2t or number times u2t with the number times u3t. Also there is u1t. So what I want to do for this one is I want to do 3 times u2t and then plus 1 times u2t. So that is, I broke that into the two terms so that I can combine this with that one. Okay, and then so this one t times u3t will be grouped to one of the t times u2t, right? And then let's keep that one as it is. Now what I'm doing is this term, okay, and then this term I want to combine that. How do I combine that? You factor out t. What is left is u1 t minus u2t, right? What is the formula for UCD? It is UCT minus UDT, right? That's why, so you can write this as TU1 to T. You see that? So that we will be able to write in the piecewise function form. Similarly, this term is combined with that term. So you will get negative, you have negative U1T plus U2T. So if but I need a negative sign in the middle, right? To write in the, to combine that. So I factor out minus sign, negative 1. So you will get U1T minus U2T, right? You will get minus and then U12T. You can write that way. Okay. So this is what you will get. T U12T from this and that. And from this and that one, I get U1T only. And now what is next is, look at this one. Negative T U2T and then positive T U3T. So negative T U2T and then plus 3 for plus T U2T, right? Plus T U3T. That's what you get. Let's take negative T out. You get U2T minus U3T, right? Because you are factoring, you are taking a negative T out. So this is basically negative U23T. You see that? That's how I got negative T negative T. I forgot T there. So negative T U23T. And then the last one is 3U23T. How? Because there is one 3U2 and there is another one 3U3. So I took 3 out. So you will get U2 minus U3. That is U23. Okay. This is what you get when you combine. So what it says is between 1 and 2, it is value is T. Between 1 and, there is U1 to T and U1 to T. You can combine those two. How do I combine that? You take U1 to T out. You will get T minus 1, right? And then here also u2 3t, u2 3t. You combine those, so you 2 3 out, take that out, you will get 3 minus t. That's what you get, right? What does it say? It says between 1 and 2 the value is t minus 1, between 2 and 3 the value is 3 minus 2, and otherwise it is 0, right? So that's what we get, because all the unit function, it says that how do you define u0t? u0t is basically 1 for right of 0 and equals 0, and 0 for left side, right? That's what the u0t say, right? Okay, so how can you write these in terms of the piecewise function? Is between 1 and 2 it is t minus 1, and between 2 and 3 it is 3 minus 2, and it is 0 everywhere, meaning for t is less than 1 it is 0, for t is greater than 3 it is also 0. You can write greater or equals to 3 there, so it is 0. All right, this is how you can write unit step function into a piecewise function. Okay guys, thank you.